Well, hello everyone. Welcome to the Hazelcast Cache tutorial series. This is part 4 of the series, and in this tutorial, we will study integration between Hazelcast Jet and Hazelcast. It is highly recommended that you watch part 1 to 3 to understand this part 4 because it will build upon the architecture and the code setup that we did in the earlier parts. All right, so what's the agenda? So first we'll discuss, as usual, some of the prerequisites. Then we'll do a very brief overview of the Hazelcast and Hazelcast Jet. Both of them are similar, technology slight difference, with this being more dealing with a stream built on top of Hazelcast, which is more like a cache. We'll look at the sample architecture diagram that we have been developing since part 1. And this should be the last leg of that series where we are able to integrate the two Hazelcast clusters and able to share information between them. And we'll look at the data model. It stays the same as the last time. We'll look at the use case where this is applicable. And we'll do a very short code review for both the Hazelcast REST application that we developed, as well as the Hazelcast Jet, which is the job where we wrote the job to basically read the data from the database and keep the cache refreshed. So prerequisites are very simple. You should watch part 1 to part 3. You have, in order to do that, you have to know Java, JDK, Maven, Eclipse, basic cache concepts, messaging concepts, to understand how Hazelcast is working, and how the two technologies, the cache and the streaming, sort of work. In this one, we are just going to look at the integration part of it. So the prerequisites are basically just watch part 1 to part 3 of this series. All right, so then we look at the overview. So Hazelcast itself is a cache. It's an in-memory data grid. It's open source, based in Java, and it utilizes the cache framework for Spring Boot. So developers don't have to learn, and a new framework can use that existing one to manipulate the cache. You just have to load it in your pom.xml and define the corresponding cache objects, and you are good to go. Hazelcast Jet uses the same caching, but it is based on another feature, which is streaming. And in our case, we are streaming the data and live reading it and connecting it to a database. So as the data changes in the database, we are able to read the data and publish out the events or load it into a cache. In the last part 3, we loaded into the cache, and in this part, we are going to send this information out to the Hazelcast Rest service cluster. Okay. Coming back, let's look at the architecture diagram for this one. So our architecture diagram has evolved quite a lot from the last time. These are the two Hazelcast REST service clusters that we will we can run just one or two. I'll run 2 of those to see how and we have seen how the cache is replicated across them, and it's refreshed from one server to another server. And so that's the fault tolerant view. Even if one server goes down, if it comes back up, it starts from where it is left off, and get the cache information from the other server. In this case, for Hazelcast Jet, in part 3, we did run 2 instances of it, but now we don't need to run 2 instances. Maybe one instance is good enough for illustration purpose. The idea was, if we submit a job to one of those, the other one also picks up, and if the first cluster goes down, if you have the necessary libraries in the library path, the other server is able to start processing the same job and keep reading the changes from the database, and this one from the database, and keep refreshing the cache. This is the multicast configuration in which they are setting up these 2 nodes are setting up together in a clustered environment, and this is the test program that we're going to use to directly read data from these 2. One of them, I'll just use one of the servers to basically read it. Similarly, there is also a small program or Postman that we can use to read data from the REST from these two clients, from these two servers, excuse me. All right, so that's the basic setup. Keep in mind though, we discussed this customer cache before and customer dependent cache. This one was just ID key value pair. This was loaded at the runtime at the startup time for the REST service, REST interface for the Hazelcast, this server over here. And this one was not loaded at the runtime, but it was on demand. But what we are going to do, we are going to populate this information, this one, with the and we're going to keep it refreshed, basically this one, and also we'll populate this one, and these two will be kept refreshed with the changes in the database. And this one is just loaded at the startup time, and after that it does not refresh. Now these two are also loaded on demand when you call a REST interface, but on demand means that there is a hit to the first, and it also means that once it's loaded, it's never changes. But since we are going to keep the data refreshed for these cache 2 and this one. All right, so now let's look at go back to the agenda. So the next item we have is the data model. So data model stays the same for this case. Just load this again. It is the customer and the customer dependent object, like what we saw in the earlier parts of the series. Now we are going to load both of these into the remote Hazelcast REST service based servers from the Hazelcast job. So let's look at how the connection looks like. So for the code review, okay, so for the code review, let's look at the Jet job. So I commented out a lot of pieces here. So let me just stop all of the jobs, make sure everything is stopped everywhere. And I have some servers running in other places. So I'm going to stop all those servers. Okay, make sure there's no instance. Okay, there's no instance running. That's good. Everything is terminated. So this one is the one job that was loading the items into the cache. So this is the local customer cache that we are plugging into the customers from the customer tables, filtering out the customer and loading into the customer cache. And how this is working, you need to see the part 3 for this one. So that's one sync for this stream stage source, and the other one is this one also is a local cache for customer dependent as before, and this is customer cache with customer ID key S key, which is this one, parent child relationship. You have a parent ID and the value itself is another hash map. So hash map within hash map with the key value here is the dependence ID and the dependent object. So it's a hash map of dependent ID, dependent object as a value itself within the bigger hash map of customer ID and the dependent hash map, right? So that's what we have over here. If we go down further, here starts our client configuration. If you don't look at it, we are trying to connect with one client, one server from here. So what Hazelcast is going to do is going to try to push the data from the our Hazelcast Jet cluster, and we will only instantiate one instance here. We already checked in part 3, previous one, that we can instantiate 2 instances, and if you submit job to one and then you kill this instance, the other one comes alive and it starts processing the same job. So we're not going to instantiate 2 instances, but you can if you want to this, like you'll get just more resiliency. So for this demo purpose, we'll just instantiate one here and maybe 2 instances here to see how the cache is replicated into one server and then it goes to the other server. In this case, when you are going to provide one of the reference to the target Hazelcast cluster. So it is 192.168.111.5.801, and that is this one, right? And 5820, change it to 5820 in case you opt to provide this. You don't have to, but one is good enough, and it's going to try to call the server, and if it's not able to connect to the server, then it will try to connect to the other server if you have both of them enabled. And maybe we can try out that example, right? So let's look at the code, and then we'll play around with different features of how the cache is replicated. So what this one is doing is creating a client configuration on the source Hazelcast cluster, which is doing a monitoring on this table that over here that we saw earlier. So this is the monitoring on the table, right? Customer dependent customers. One, this is the database connection information, and two of the above sources are local caches, and then I have a remote cache. So in this one, the difference is using sinks.remote_map instead of using sinks.map. So it was at sinks.map with merging, and then you had the CDC. So there's like two classes that are kind of supporting similar map functionality. This one is doing a remote map. Remote map means on the target server, I am able to replicate the customer cache too. So if I go to the target server, we had customer cache that was loaded from the initialized, and what it said loaded Hazelcast from the Hazelcast change data capture job cluster. So that's what that really meant, is that the cluster of the jobs of the servers running the jobs will push the data to the other Hazelcast clusters. All right. So here you have, again, you're putting the same customer ID and customer whole object into the memory. Keep in mind though that object must exist. So right now I just copied it as is, but so on the target side, on the target server side, the customer exists in the same schema. Why am I not seeing this? Yeah, here it is, right? So that customer must exist on the target side. Okay, so in order for you to be able to load it over there, otherwise you'll get class not found exceptions. Now I tried other methodologies as well. That was not successful. So when I tried to load this remote map with merging, it kept giving me data serialization. So this is what I was planning to do for customer dependent, because dependent is not referenced by ID, it is referenced by the parent's ID. This data structure that we have discussed many times, and it kept giving me this one, so I didn't pursue further with it. But probably some Hazelcast configuration that we need more input on to see why it's this one happening. But it was essentially doing the same thing. If it does not exist, just create a new hash map and put the first dependent in there. If it does exist, if the hash map exists, just put the new value into the old hash map, get the new value out over here, put it into the old hash map over here, and now you have the new value. If in the old hash map you also have that new value, it means that this likely is a data change on an existing dependent that is already in the cache. So we are refreshing the cache, we are overwriting that. So we get that old hash map, this one, and if we find a dependent there, this put operation works both ways. It will add the dependent to the hash map, and it will also overwrite if it finds the dependent. So it works both ways. Okay. I was not successful with that. I was getting this exception over here, data serialization factory. Then I tried another approach, which was topic. So I was trying to send it to a remote topic, which was customer dependent cache topic 2 with customer ID as key. So this now comes back to, in part 2, what we did not cover was this part. Cache startup event listener. Okay, in startup event listener, what we have is two topics that I am trying to register, and this is the second topic that when I send directly to it, I was not able to receive. Maybe some configuration, something little that's missing, and I'm not able to receive. But then the last thing that I tried that really worked, I go back, is so I was trying to sync to reliable topic that did not work. That again, customer dependent, was not able to get messages. Then the last thing I tried is to basically create an observable. So this observable is where you can write the code. It's like, okay, what do you want me to do with this data? So over here, I registered an event kind of thing. Like, so for example, created an observable, and I added an observer to it. And what it does, it creates a topic for the client instance for this one. Client instance is, where did it go? This one. So for this client instance, it creates a topic. And then it is able to publish the topic to that client. So customer ID. So this is the one that I was able to receive manually. So I'm creating an observer. And then I am to the sync to this stream straight source. I'm syncing, and I'm saying that I'm gonna write to sync over here, and this one syncs not observable. This one observer. So I created an observable object, and I was able to sync the information here. And this should take the value and call this operation when it gets a new customer dependent or change in the customer dependent. And that's this one. And change the customer dependent, send it to the client. Yeah. So when it goes to the client, it will go to this topic on the client. So if I go back to the client side, or the server, which is the destination for my topic, it is this customer dependent cache with the topic with customer ID as key, and this was topic 2. When I used the direct reliable topic, I couldn't get it, so I had to create a manually coded myself to send the data to the topic. So this customer dependent topic with customer ID as key is the one where I'm going to receive the topic. So I need to manage the cache myself. Now what do? I'm just getting a customer dependent object in there. So what this one does, it registers a listener, this one, message listener, and I have 2 message listener. This is the one where I was trying to get the customer ID topic 2, which is the second one, and I did not get it. So this is the one I ended up using manually, where I'm sending the data manually. So what this one is doing is, I guess the message prints out just for my information that I received information into topic 1. And what it does is customer dependent cache with customer ID as key. It tries to get the cache, and then from the cache it gets that for this new customer that's coming in, which is customer dependent, and this customer dependent, I was able to see, where am I getting this? Yeah, customer dependent, this one. Yeah, so this customer dependent, which I got in the message, using its ID, I tried to access the cache and see, do I have already this customer in the cache? And if it's using its customer ID, do I have this, like, for example, using it the customer ID, using the parent's ID, I try to get the hash map for the customer dependence. If it is null, it's going to create a hash map, put that first item in there, which is the ID of the, not the customer ID, but this ID of the dependent. Again, remember, the dependent has 2 IDs. I go back. Dependent has 2 IDs, the ID and the customer ID, the parent ID and its own ID. So using its own ID, I'm putting the whole dependent object in there. And then I add this hash map using the customer ID, the parent ID of the dependent. So then this hash map goes in here. Okay. Now, if you already have it, what's going to happen? If you already have it, a hash map, you will come over here. Okay, I already have this hash map. So what it does, it tries to get the wrapper. Using the wrapper, there's some wrapper concept in the cache. It gets the customer dependent cache dot get the hash map. So now you have a hash map for that integer and customer dependent, right? So you get this hash map. Okay, you get the hash map straightforward. And the hash map, what it does is basically puts the new item that we just got into the same hash map, and then add the hash map back. You have to add the hash map back. It won't automatically add. It's kind of get by value. So when you're doing this from the wrapper to getting the hash map, you are actually getting this by value. So you have to put this in the customer dependent cache. You have to put that the hash map again. So in the hash map, we put the new customer dependent using the customer dependent ID, and then into the main cache, we put the whole hash map again. We got the whole hash map, we put the new customer dependent in that hash map, then we put that whole hash map back into the cache. So now we have added the new value. In case the dependent already also exists, it means that this operation is going to, so if I write the comment over here, it will be this operation either adds the dependent to the hash map or replaces if the dependent already exists. So the dependent already exists, we just replace it. Okay. All right. So now let's time for us to do the code review, the demo for this one, and see in different. So the first thing I'm going to do, I'm going to run that job, run two instances of this server. So one is on my local machine, 1111, and one on 150. So 1111 is this one and 150 is this one. So I'm going to run the two instances, right? And I will only connect to one instances, and you will see both of them will start getting the values. So okay, and we will use both the ways to see what's going on in the cache. Okay. Okay, so the first thing we do is let's run this instance. So I'm running the first reference data server. Okay, my REST service, server. So I'm gonna run server, make sure that its port and host are 5801. Good. Okay, once it's connected, I'm going to run the this one to see what's in my cache basically. So this one is connecting to the local 192, which is the same one, and 5801, and it is trying to get to the Hazelcast cluster instance, and it is trying to get the customer cache 2, and customer cache with customer ID cache dependent customer dependent cache with customer ID as key. So if we run this, let's see what do we, it's able to. So this application is this one. Okay, so let's see what we are able to get from the server for this. Go back to the, okay, we got customer. So remember, this was loaded at, if you watch part 2, you know that this was loaded at the startup. Going back to a startup, so we are loading this. If it is null, the first value, we check this one. If it is null, get customer init value, then we load up the customer manually by making a call to the database, put if absent, and hash full, and then it basically puts all the elements from all the records from the customer table, right? And this is where it's putting in, and itself is repository. This one is a call to the customer table, right? It's a customer repository. So that's what we studied in the previous parts, and it's able to load the customer information. So we have the customer. So now let's do the postman, and with the postman, we will maybe call one customer for cache, customer 2, and one dependent. Okay, so let's make sure it's 192.160 customer ID. So let's make it a call for 1002. First, make sure that 1002 does exist. So yeah, 1002 has 3 dependents. So we just make a call for this one, and then we see what happened with the cache over here. So we'll load by 1002 and should see some, maybe some, okay, here. Yeah, so it hit the DB first time because I called it for 1002. Now 1002 should be in the memory. If I call again, it should not hit the DB. So yeah, it's able to call, and you should be able to see the time would be much different if it is already in the cache. Now, in order to ascertain the fact that this is in the cache, we run the test again and see what we get this time in from the cache. So if we run the test again, if you see, we get following dependent. Okay, I just want to make sure I ran the dependent. Excuse me. I ran the dependent for this one. Yeah, I ran the dependent for 100. So 1002 is there. How about we do customer cache 2, customer ID 2, customer. So in this one, we just provide 1003. And then see the response time 1093 millisecond. Do it again. 213. Okay, let me try that again. Okay, much faster, 22 milliseconds. Okay, maybe some network latency was there. Okay, so let's go back to see what's going on with my server over here. So I made a call to, so the first time over here, there was a customer cache 2, and that was a hit to the DB, and this information is now loaded into the memory for 1003. Similarly, 100, so this is 1003, and 1002 we just get the dependent, and 1002 we get the customer 2. So now if we run the our test program, it should be able to show you that we have all this data loaded into the memory. So now if you look at run it, it finishes very quickly. So we were already getting all the customers in customer cache. Customer cache 2 has one customer, and customer ID with dependent as this one. So just a quick look in the customer controller. So the customer controller is where the cache is being managed, and customer service is where the cache is being managed. So if you look at the customer service, customer cache, you get everything from already loaded, so it will never go to the DB. Customer dependent cache with customer ID as key, right? This is the one which was, we did the code review for this one in part, I believe 2. And this is the one where if you don't have the ID cache with ID as key, then it basically makes a call to the database to try to, load that. And then next time when you have it, you're only going to get it from the cache. So now you only have one item in there. And remember, we are maintaining this whole customer dependent cache. So now we have one item in customer cache 2, and we have one item in customer dependent. All right. So now since these two are loaded, now what we are going to try to do is basically run our connection job that will load the data. So let's run it from the server this time. So let's build it. So right now we're going to build this thing. After building it, we need to copy that. If you remember, we need to copy that target. So let's see, is my target 818? Yeah, that's correct. So I'm going to copy this target to the library folder. Now it's asking me, does it want to replace? So I replaced it. Now I'm going to run the Hazelcast Jet. So I'm running it from the server itself instead of Eclipse. Jet start. That should start my Jet server, and then after it's started, I need to submit the job to it, and I have to make sure that I am running my server over here. All right, and how about I also run another server, which is, so basically I'm going with this full configuration. If I go back to my Hazelcast, where did it go? Yeah, here it is. Hazelcast instance. So now I'm running these two servers, and I'm going to run one job instance that was going to populate. And when it runs, you should be able to see that it's able to find two servers in it. Okay. So it started at the server at 111.5950. This is the configuration for the Hazelcast server, like the one that's going to run the job. Make sure the Hazelcast.yaml have 5950. This is the one that's a standalone server. The well, it's a cluster server, but it's outside Eclipse server. It's now ready to connect with the two, but I haven't submitted the job yet. So before submitting the job, let's start the other server. So here, make sure everything is stopped. Yeah. Now it's going to start and become part of that cluster. So this one and the Eclipse over here should form a cluster. This is on my local machine. All right, so it's communicating with one another, and it should soon identify that, yeah, now two servers are part of this cluster, 5801 and 5820, 1111 and 1150, 150, right? So two servers are part of this cluster. Now we are going to submit our job, and remember that our job over here is connecting only with first server, and it's able to, what I really want to show is that it's able to discover the other server and also connect to that, and like these two servers will share the, like the one that we ran in Eclipse will be able to share the cache information. If I go back to my Hazelcast, we're able to share the cache information, right? And be able to, even if I connect to one of them, and you will see if I bring down this one still keeps getting the updates. So Hazelcast is smart enough to basically from the cluster discover what are the servers in it and able to send the information to. So now going back to submitting the job. Time for us to submit the job. Where did it go? Where did my go? Partition, not this one, here. Yep. So now I'm going to submit the job. We already saw the command for it, and let's submit the job for this one. So when we submit the job, see, it's able to, all right, let's see, is it able to detect both the servers or not? So I'm just trying to look for the log if it's that somewhere it's able to select. And keep in mind though, it's also loading it to its own local cache, basically. All right. Yeah, it did. So here it printed out which servers it's connecting to, right? So it tries to connect to this one, and it's able to find 2 servers there, and it's able to connect to those servers basically. So both of them should start getting the update. So now, in order to do that, to see whether my other Hazelcast server has those, what do I really have in my Hazelcast instances now. All right, so if I go back, I'm going to run the cache Hazelcast. So first I'm going to check the 111.158.0.1 server, and let's see what I get over here. Okay, so if you see, first thing I got is I got all the customers in cache 2, means cache 2 was fully populated, and dependents are also fully populated. We didn't have this before. Now we have all the dependents. But why? Because I submitted the job. Okay, if I hadn't submitted the job, you would only see one over here that we were seeing before and one over here that we saw before. All right, now let's connect to the other one, and let's see what I get from 150. Okay, so that's the 151. So I'm gonna try to connect to 150. Oh, it's gonna restart. Yeah, it restarts the server because it's a part of this class, but maybe I should have kept it separately. So let's start the server. So I'm able to connect to 150, and you will see that the 150 also has all the items from, because they was loaded at runtime by the first server at 111, then it passed on to 150. Then the job loaded the other 2 items, and it passed on to also to the server. Then we got the 3 items dependent also passed on to the other 150 server. Okay, so now we have everything in the cache. Now if I change the value in the database, you will see the job is actually submitting what we configured. The job is to submit the value to here, but you will see value appearing here as well. So if we directly change, and this is where the refresh part of the things comes in. So if I change this to Dawn number 2, let's try that. We say apply, sets the number to number 2, it applies, it updates, executes this update statement, finish. Right, so let's see what happened with the cache. First, let's look at the job, and you see Dawn number 2, it's able to cache, and some of it is caching internally because we did not disable the internal cache for that server. And then it's also passing it on to the 2 servers, REST services that are running in the cluster. So if I go back to that service and I run this one again, you see it's Dawn number 2. So the second server got it on, obviously the first server already has it. So now what happens if I stop the first server? So if I go there and I stop this first server, and remember we communicated from here to the first server, but since those 2 servers are in a cluster, it will still keep sending the data to the second server basically. Okay, so if I go back over here and so let's try that, finish. And one more thing, so we should be able to also see that information here. Yeah, so it received Dawn Travolta, so that's also our confirmation. If we want to directly use this configuration, we can also run this client program to connect to the server. So it's 5820. Yeah, it's able to get it. It's still waiting for that first server. It could not get it, so it tries 5820 and it's able to get these. And here it is, Dawn Travolta. So it was in the middle of, because I stopped the server abruptly, it was in the middle of confirming that the first server is still going away. So it is still considered first server, but when it didn't find it, it just went to the one that I provided, right? And it's able to find the Dawn Travolta over here. So you don't have to have all the servers running, even if you submit a job and such that your Hazelcast Jet instance is connecting and pushing the data to one server. If this one dies, this one takes over, and Hazelcast Jet automatically starts pushing the data to this, this server as well, because they were part of the multicast, cluster. All right, so that's the case of refresh. Now, one thing I'd like to show you, remember that this customer 2 is being refreshed while customer is not being refreshed. It was loaded at the runtime. So if we change something in customer, you will see those two caches will differ because we didn't really do anything with it. So if I just change to Annabelle and I say fly, finish, you will see that will still say Anne, and this one should say Annabelle. Okay, so if we run this again, it's gonna, right? So you will see it is still said Anne, and it said Annabelle because we are pushing the Annabelle to the topic I'm printing, but Annabelle, that customer 2 is directly being populated into the map. So that's the difference between customer and customer 2. Customer 2 is a static cache loaded at the runtime, startup time. This one is dynamic cache refreshed on a regular basis by the Hazelcast Jet Cluster. All right, so we saw the working demo of the Hazelcast and Hazelcast Jet, and now that's one more thing before we end our session, is that we look at the use cases. So we already have visited these use cases, so just for refresher. So it's primarily this kind of architecture is for reference data lookup that you want to maintain in cache, and then you want to keep refreshing over time as it changes. You really don't want to use this on a transactional data that is changing too frequently, and it's probably not going to be need to be distributed across different nodes and need to be refreshed because maybe say a specific node is already dealing with it, and you might as well just read the transactional data rather than maintain it in memory and every place where it's not going to be read. So good use case for a data refresh for reference data on a regular basis without having to turn down the servers, like sort of keeping the servers hot and maintaining that information without having to do a full redeployment and restart. So low latency reference data and keep the data refresh on the DB, fault tolerant. Both the REST service Hazelcast clusters as well as the Hazelcast Jet clusters are fault tolerant. If one of the REST service server node goes down, the Hazelcast Jet is able to send the data to the other server, even though you didn't say even provide that in the as a client configuration parameter. Similarly, if one of the server of the Hazelcast job which is executing in a node goes down, we saw that in part 3 goes down, then the other one is able to pick up, as long as it has the library, is able to pick up that same job and start reading from the database and start pushing the changes onto the cache. Resource consumption is an issue. Memory could be an issue. Get too much data that you load in there, and that could also be an impact on existing application in case you have failures or code issues or memory leaks, those kind of things. So you have to sort of watch out for that. So it's like you get something like speed and performance and low latency, then you give up something which is the resiliency of the other applications, especially if they're running on the same node. All right. So that will be the end of this session. Hope to see you again in other series that I'll do on this channel. Thank you all.